And I'm not going to read this entire script because that is way too much work. So I'm just going to use AI voices. First, you have to have all the ingredients. You'll need at least 3 grams of copper. I got mine from stripping Ethernet wiring. Do not use pennies because the zinc inside them will react and make explosive, flammable hydrogen gas.
You also need 140 milliliters of 4% white vinegar. In addition, you need at least 100 milliliters of 3% hydrogen peroxide. Technically, you only need 10 to 30 milliliters of it, but a lot of it will degrade before it has time to react, so just have at least 100 milliliters. Next, you need 250 milliliters of standard concentration. Household ammonia, usually 3-ish%, try to find clear ammonia, because it will have the least amount of additives like scents or surfactants that can mess with the reaction. Finally, you need 11.5 grams of unscented pure Epsom salt. This shit really easy to find. So don't stress about it, gang.
The first step is just to measure out the 3 grams of copper and 140 milliliters of vinegar and put them into a beaker and bring it to heat. I used a 250 milliliter beaker, and I would say that is the smallest you should use.
After you have brought the vinegar and copper solution to heat, not quite a boil or simmer, but still hot, you are going to slowly add in the 100 or so milliliters of hydrogen peroxide. You'll notice that as it gets hotter and over the course of time, the solution will turn a turquoise blue color. This is because of the formation of copper acetate. The hydrogen peroxide oxidizes the normally chill and nonchalant elemental copper into its 2+ oxidation state. In this 2+ oxidation state, it will bind with the negatively charged acetate ions from the vinegar's acetic acid. Each copper acetate is a single copper 2+ with 2 negative acetate ions. For the formation of our purple Tetraaminecopper 2 sulfate, the acetate isn't important, but it is the easiest and most simple way to get an oxidized copper for the ammonia reaction later on, as normal copper wouldn't react with ammonia. If from the start we were to have used copper sulfate, this part wouldn't be necessary as the copper from the copper sulfate is already in an oxidized form. But that is lame, and this is a more fun way to do it, without having to go to the hardware store and buy copper sulfate root killer. It is paramount that the hydrogen peroxide is added slowly. This is because the reaction releases oxygen gas, which causes the solution to bubble immensely. I almost caused my solution to bubble over because I was being a careless goon. Don't be like me. Also, this AI voice generator is only letting me generate 2 text, so you're going to be stuck with this character for a fat second. Even though we added over double the theoretical stoichiometric amount of hydrogen peroxide, there is still going to be unreacted copper. That is simply just the nature of this reaction. I let mine react for 3 hours, and it still wasn't done even on full heat. There is no workaround other than just letting it run its course. An issue you might run into is that as the solution evaporates, the copper will begin to be exposed and will not react. To fix this, you can simply just add some distilled water, not any of that tap water shit, because it has impurities that can ruin the crystals. Once it has reacted enough, take it off heat and let it cool down. Then once it has cooled down, filter it through some coffee filters or whatever, mainly just to filter off the stir bar and copper. Do not put this beaker away yet, because we will still use it, and by that I mean I'm going to use it right now, in a separate beaker or grad flask. Measure out 250 milliliters of ammonia. Because I used the same beaker from my copper acetate, you can already see some purple formation happening. Then pour this into your copper acetate solution, which you hopefully put into a larger beaker, like 1 liter or something. You should immediately see the formation of a deep purple complex. Just listen to my reaction.
Holy shit.
This is because the copper acetate reacts with the ammonia to form Tetraaminecopper 2. which is a copper 2 plus ion and 4 NH2 groups. Let this sit on low heat and stir to fully react for a few minutes.
Okay, thankfully, I can use a different voice now. Right now, our solution contains the Tetraaminecopper 2 complex, but we cannot isolate this complex because that is not how that works. This is only a positive ion, and to form a stable crystal, we need to add a negative ion that this Tetraaminecopper 2 complex can bond with. A comparison would be like having only Kl- in a solution and trying to isolate it. You need to form it with a positive ion like Na+, to form a stable salt, which for that would be sodium chloride. For this reaction, we are going to introduce a sulfate ion. Again, if we used copper sulfate at the start, this wouldn't be necessary, but I really hate copper sulfate with all my heart, so don't even get me started. Instead, we are going to be using Epsom salt. Epsom salt is known as magnesium sulfate heptahydrate. We don't care about the magnesium and its 7 water molecules, just the sulfate ions. We will start by measuring out 11.5 grams of our unscented pure Epsom salt, then adding just enough distilled water to dissolve. I put this on heat and stir to help dissolve, but it isn't necessary. In fact, after it has dissolved, we need to let it cool down, because heat might destroy our crystals. After it has cooled down, add it to the purple solution. It should immediately cloud up. This is hopefully due to the formation of tetraaminecopper 2 sulfate in solution, which at this point is just microcrystals that look like dust. This dust will slowly, and by golly on golly, do I mean slowly, start to settle down to the bottom. This was a 10-minute time lapse, and it barely moved at all.
The crystals, if present, are going to take a while to form. So while it does that, let me tell you how to clean up this bluey, ooey gooey mess. We can't just take it to the sink and wash it out because copper compounds are incredibly harmful to aquatic life, and it's also illegal. Instead, we will use vinegar and hydrogen peroxide to dissolve the copper off the beakers and tools, then collect it into a copper waste container. Get your vinegar and hydrogen peroxide, pour some into a dirty beaker. Then use a plastic spoon or glass rod or something of the sorts that you don't plan on eating from, and dislodge the copper from the sides of the beakers. It helps if this is done on low heat. Try and dislodge all of it without collecting any on a paper towel if possible. You can use this same solution in your next beaker to dislodge the copper from it. Afterwards, pour the waste into your copper waste container and repeat at least 2 more times with fresh vinegar and hydrogen peroxide. You can use paper towels to pull off really stubborn bits, but only as a last resort. After the vinegar washings, you need to do a few water washings to collect any final copper. Do this a few times, and then, and only then, can you wash out the beakers normally. Eventually, you can reduce this waste by boiling off the water and concentrating it. You can either then try and find a use for the copper in solution, convert it to a solid copper salt, or take it to a waste disposal company.
You can speed up the crystallization by using very low heat to drive off the liquid. There is probably still plenty of ammonia, so do this with good ventilation because ammonia smells like strong piss. You can see here that the top of the solution has turned glassy as the crystals form and rise to the top of the
Someone
solution.
tell this AI voice
You
to
can
shut up.
force
Why
the
he doing
crystals
too much,
to
bro?
crash out of solution with ethanol, but it is not necessary. This was one of my first crystal samples I was very careful with. You can see its obvious blue color and long spiky structure, which is representative of the structure of Tetraaminecopper 2 sulfate. In comparison to actual samples of Tetraaminecopper 2 sulfate, mine looks like a failure. But the reason why mine isn't purple is probably just because it has much more water in the crystal lattice. The purple sample is monohydrate. Mine is probably hexa, or heptahydrate. But yeah, that took forever. Final yield, 10.5 grams,